Algebra 2. How are we doing, guys? All right, we're back again. Here we go. Section 8, Chapter 5. We're jumping into what's called curve fitting with quadratic models. I'll be honest, these notes are really important. All right, I know I probably say that all the time, but this is one of those sections, like you remember when we had the quadratic triples and you had to solve for x, y, and z? This is kind of like one of those. So pay close attention, follow the example problems very closely. You'll be okay. All right, ask questions. If you are in class, make sure you're asking questions. If you're not in class and you're at home, email me those questions or send them through Google Classroom. I'm going to do everything I can to make sure everybody is where they should be. All right, so let's jump into it. So here we go. We are basically determining, as this says, whether a data set, so in other words, you got your x and y coordinate, a data set, is a true quadratic function. That's the first style of problem you'll see. Starts out nice and easy. All right, so these are the 3 steps that you always take. Step 1, make sure, it says hat. Let's put a T right here. Make sure that, nice little typo, all the x values are equally spaced apart. All right, so that's step 1. Make sure every x value is equally spaced apart. If the x values are, move on to step 2. Then you're going to find the difference between each y value, and that is the first difference. All right, so we call that the first difference. Take every y value, find the difference between. That just means subtract, all right? So if you would do that, you would take the second y value, minus it from the first, find that difference. Then the third y value and minus it from the second. Okay, so you're going to do that all the way through, find the first difference. Then move on to step 3. Take the differences of all those first differences. All right, and no shocker here, that's called the second difference. And what you're looking for is to see that the second differences are all the same. If they are, this is going to be a true quadratic function. If they're not, then it's not a quadratic function. All right, so let's go through an example problem and do just that. Step 1, are all of the x values, as it says right here, equally spaced apart? We go 3, 4, 5, 6, 7, yes. All right, so step 1 here, x values are good, check. Okay, now step 2 is we now need to take the difference between all of the y values, and that's going to be called the first difference. All right, so we got 21 minus 11. So our difference right here, we got 10. Then we're going to have a difference right here, 35 minus 21, 14. Our difference here, 53 minus 35, that's 18. And last one, 75 minus 53, 22. So what we're looking at here is this is called our first difference. Okay, first difference. Now let's work our second difference. Now it's going to be these guys, 14 minus 10, we get 4. 18 minus 14, we get 4. 22 minus 18, look at that. A little bit of magic here. Our second difference, boom, they are all the same number. So if you take a look back at step 3, if the answers to the second difference are all the same, then yes, we do have a quadratic function. Okay, yes, we do. All right, so that's the basics of what you're doing here. Step 1, take a look at the x's. Are they all going, as the phrase says, equally spaced apart? Then move into step 2, calculate the first difference. Then step 3, calculate the second difference. Now this is important that you guys remember, calculate second minus the first. Don't go first minus the second. So you notice how I did 21 minus 11. I didn't do 11 minus 21. Okay, so go in that order. Second minus first, third minus second, and so forth down the line. All right, now here we go. To write a quadratic function, it's going to be given 3 points. So in your problems, you're given 3 points. Step 1, find the point where you have a 0 for x and then a number for c. In this case, a 0 for x and a number for y, but that number for y is going to be your c value. All right, that's step 1. Find that point first, because that is what sets everything in motion and then allows you to start working the problem out. All right, so here we go. Remember, it's very similar, like I said, to the triplets, but now we're doing ABC, standard format. Let's just jump into a problem right here. Okay, so we have our given values, and what we're going to do is we're going to focus on this guy first right here, because that is where x is a 0. So that means that we have our c value. C equals -3. Okay, and what we're going to do, you remember when we did the triplets and we had to number the equations? We're going to go back to that. Number this equation. This is equation 1. Okay, and by the way, we already have one of our values. There's c. We just need to get a and b. All right, here we go. So equation 1, now equation number 2. So here's what we're going to do. The format is right there, ax squared plus bx plus c, and we have our values. Now we're going to use this guy right here. This is our x, this is our y. So we go 0 equals a times 1 squared plus b times 1. And now we're going to actually substitute c in, which is -3, right? Because we have our c value, so substitute that in. Now, if you work this out, 1 squared is 1, 1, all of that. This simply works out to just be 0 equals a plus b minus 3. Now let's take that -3, move it over there. So you have 3 equals a plus b. Okay, and what we're looking at here is, now we're going to call this equation number 3. Okay, hold that equation right there, because we're going to use it in just a second. All right, let's go back, and now we're going to use our final point right here. Here's our x, here's our y. So we have a 1 equals a 2 squared. All right, we're just substituting in the number 2 because that's the x value that we're given for this coordinate. And plus b times 2. And remember, we have c. C is that -3 right there. So now let's simplify this all down. And we have 1 equals 4a. I think the format, it looks a little bit better when you put that coefficient in the proper spot. All right, plus 2b minus 3. Now we're going to take that -3, and as we did before, we're going to move it onto that side. And so now we have 4 equals 4a plus 2b. Okay, so now we're looking basically like we now have our equation 4 right there. Okay, so now, just like we did with the triplets, we need to isolate one of these variables, solve for it, and in this case, let's use elimination. All right, so let's set these equations up here. We're going to go with our 3 equals a plus b. We're going to put that on top. Right below it, we're going to go 4 equals 4a plus 2b. But this guy isn't set up properly. All right, so which variable do we want to cross out? Let's cross out b. So let's multiply this entire equation up there by a 2. All right, and that's going to now give us 6 equals 2a plus 2b. And then underneath it, 4 equals 4a plus 2b. And we're trying to cross out the 2b and the 2b. Notice they're the exact same sign. So that means we have to use subtraction. All right. And these guys would cross out. And then we would have a 2 equals a negative 2a. A equals negative 1. And then what we could do, and let's see. All right. We're going to take this value right here, and we will be plugging it into right up there, equation number 3. All right. So let's get a little bit more space. Now we have 3 equals negative 1 plus b. What is b? B equals 4. All right. So now what we have our A, we have our B, we have our C. Now we have to put it all back together into the standard format equation. All right, so let's do that as our final step. We're going to go negative, start with f of x function equals a negative 1 x squared plus 4x minus 3. Now we are in business. There we go. That's the whole process right there. All right. Rewatch that. If you need to see it, I'm actually going to do one more for you. All right, here we go. So let's go through this whole process again. Here we go. Which one do we like the most? We like this one the most, right? That's where x is equal to 0, which means, boom, our c value equals 4. That is one of our necessary pieces. Okay, let's do this one. So here's our x, here's our y. So we have 8 equals, all right, if we plug in a negative 1, you guys remember a negative 1 squared is just 1. And the only thing it's going to change is our b value. B times a negative 1 would be a negative b, right? So I'm kind of jumping and saying we're going to have a minus b plus 4, right? Because we have our 4 coming from our c value. And if we square negative 1, because remember it's the whole ax squared, we're going to get 1. And then b times a negative 1 makes a negative b. Now, let's take the 4 and move it right over there. And that's going to give us 4 equals a minus b. Okay, so don't forget we got equation 1 right here. We got equation 2 right here. Again, if you remember and you want to number these equations, it might be helpful just so you don't get so many equations on the page that you forget about. All right, let's do this guy right here. Don't forget there's our x, there's our y. 2, all right, 2 equals a parentheses 2 squared plus b parentheses 2. And then our c value was already given. We solved for that. That's 4. Simplify this down. 2 equals 4a plus 2b plus 4. All right, take this 4, bring it over here. And then we're going to be getting a negative 2 equals 4a plus 2b. And hopefully you're starting to see this process. Now we need to use elimination because we have equation 2 and we have equation 3 right here. So let's go ahead and use elimination, set them up. But which equation are we going to work with? All right, let's go. We got 4 equals a minus b directly below it. We got our negative 2 equals 4a plus 2b. And let's eliminate, let's go and eliminate the b value again. All right. So we're going to go parentheses, multiply everything by 2, creating 8 now equals 2a, right? We just distributed this guy to all parts. Okay. 2a minus 2b. Directly underneath it, let's write what we have for equation 3. Okay, now what you should see is we have a negative 2b, we have a positive 2b, so we got to take those out, and the arithmetic we would use here is addition because the signs are opposite of one another. So gone and gone, giving us 6 equals 6a, meaning a equals 1. Don't forget we already had c. Now we have a, and let's take that value and plug it in right there. So 4 equals 1 minus b. b equals a negative 3. And now we have our a, we have our b, we have our c. Put it all back together so that it looks like a true quadratic standard form. So here we go. F of x equals a 1x squared minus 3x plus 4. Ooh, boom. There we go, guys. All right, I understand that videos that get a little bit long or have a lot going on can be a little bit difficult to stay up to, but please watch this, rewatch this, copy every single bit down into your notes. Ask questions if you got them. You guys can do this. All right, see you in the next one.